Yeah, ready?
Okay, hello, welcome everyone. I can see some people are still filing in. If you could just kind of discreetly find yourselves a seat, that'd be fantastic. So, to introduce the second half of this afternoon's talk before the final break, I'd like to introduce Behzad, and he's talking on scalable forecasting in retail, challenges and opportunities. Behzad started working at M&S in January 2021 as lead data scientist as part of the data science retails team. He is involved in the digital transformation of the retail operations using machine learning and artificial intelligence. Can we get a round of applause for Behzad, please?
Thank you very much. Okay, thank you. Okay, welcome everybody. So this is meant to be a two-people gig. But you know the second part, John Mendenhall, is not here. And the reason is that John and his wife, they are expecting a baby. So if you see, we look at our mobile phones, we are looking for good news. So let's see how it goes. Today's talk is about the scalable forecasting in retail. We want to talk about things that we learned by doing this project. Now, the talk is organized in two sections. The first part, we talk a little bit about what is the relevance of forecasting to retail and what type of things we do in M&S when we use forecasting. The second part is a special, a small use case that we are going to talk about. And that is really about sales probing, and you will see in a second. So Marks & Spencer is an 11 billion business. We have both online and digital business, and also we have stores. We have 1,500 stores. In the UK, 22 million users, and out of those, 15 million of them carry loyalty cards. So it's a pretty large business. And forecasting is an important part of this business. So it's used in various things. I tried to put some of these items here so that we can look at them briefly. So inventory planning, we are in business of buying and selling things. We should know how many pairs of jeans we are selling before we go and buy, right? Supply chain optimization, look at this store. This is store, how many jeans they are selling, what is the sell rate, and on the basis of it, how many pairs of jeans we need to send to that store. I'll talk about sales probing in a second. Markdown, imagine if we are in sales, at what point of time we need to reduce the price of an item, the price of jeans. Waste management, at what point of time during the day we reduce sandwiches so that they don't go wasting. My immediate team is very much aligned with sales probing and labor planning. So sales probing is really about looking what items are sold within a store. So this store is very similar to this store. And we predict that this store is not going to be selling as much as the first one. How can we help them to achieve their objectives? So there is forecasting there as well. And labor planning is about how we place colleagues at the store so they can serve our customers. It's not just about making money. They are very, very tight constraints. So for the sake of argument, you're probably not aware of this, but if we sell items which are out of date, each one of those items we get fined for £5,000 or 6 months jail. And in Republic of Ireland, it's like 3 years jail. So these are serious things, and we need to be really careful how we plan our resources so that we don't end up in that sort of situation. So we have forecasting in that sense as well. So considering all these diverse set of use cases, my colleagues, data science colleagues, they use various techniques. So classic machine learning techniques, flavors of ARIMA, exponential smoothing is used a lot. This talk is about profit. We use profit and neural profit as well. Just let me give you an example of something that we do in Marks & Spencer. So imagine we are developing a use case for 400 stores, right? So 400 stores. And these scenarios are developed for, say, 50 categories, right? So 50 categories, a category like jeans. Each one of these categories, they have subcategories, like, for example, skinny jeans, say. So it becomes 4 times 50 times 10. You've got hefty number of models, basically. So if you multiply 450 and 10, you know, mathematician can't count, but it's 200,000 models. So we are running and tuning 200,000 models in weekly or sometimes daily prediction. It's quite a bit of computation, quite a bit of engineering. These models, they have lots of seasonality. And also, we have another thing which is very important to us, and that's called explainability. So at any point of time, when we give a forecast to a store, a colleague from a store can call us and say, this thing that you are saying, why are you saying that? So it's important for us to be able to justify and explain and basically describe the reason for what we say. And our data is big data in a sense. It goes back to decades, as you will see in a second. So let me talk about profit a little bit. I know there are people here who use profit a lot. This is a very nice time series. It's one of these products in one of the stores. As you can see, we've got all these seasonality across. And around Christmas time, you see shoots up. So we sell a lot of whatever this item is. The way that profit works, it works on the basis of modular compositionality. Every one of these points basically gets broken into sums of some values. So for example, the values which are trend, seasonality, and the effect of holidays. So if I take this point, which is like 10K, if I go and identify, this is 2014, this value, if I go and identify this value, add them, the sum of these is very close. This is the error term that you have. So modular compositionality allows us to break this into parts that we can talk about. And that's very important to us. We can speak to our colleagues, and they can communicate very nicely. Oh, by the way, the trends in profit is done by a piecewise continuous function, pieces of line, as you can see. And the seasonality is done with the help of sum of Fourier transformation. And this is a mass function, as you see, across time. So that's very nice. Good. So this allows us explainability that we like. OK, so this is the same time series going to 2022. What is this thing here? Anybody knows? COVID, blasted COVID. This is the COVID. So profit also helps us with that. So if you take this, replace it with null, and then you know the way that profit works behind the scene, it uses Monte Carlo simulation. So it simulates that part and basically says to us, what would have happened if there wasn't any COVID, in a sense, right? So these are some of the reasons that we opted for profit and using profit in our line of work. OK, very good. So let's go back to the question of scalability. So in sales probing, as I said, if you look at this combination, you know, 400 stores, 50 categories, 10 subcategories, we are talking about 200,000 forecasts, say on K this weekly. So how do we scale this? The way that we scale this thing is, I mean, these are 4 of the things that we do. So for hyperparameter tuning, we use HyperOpt. We built everything at the back of a Spark. And we use vectorized UDF. Our data is on Azure, and we use Databricks. And then we spent quite a bit of time designing good pipelines. And finally, we spent a fair bit of time working on our I/O. You know, we studied our I/O, and we tried to optimize that a lot. Otherwise, we wouldn't be able to do things at this scale. So I'm going to talk about each one of these a little bit to see how everything fits together. Yeah. So profit itself, beautiful as it is, it comes with its own hyperparameter tuning framework. And the way that it works is on the basis of biases. There are a set of priors that we adjust those priors. So for example, there is a prior for holiday, basically saying what is the effect of holidays. And the value for that is 10. And you can increase and decrease that. So if you increase the values, it makes your model more flexible and the chance of overfitting. So what we do, we adjust these parameters in our hyperparameter tuning. It's based on the maximum a posteriori estimation. So how much resources really we need to do? So last night, I said to myself, let's create a grid search of size 120, like 5, 4, 3, 2, and see how long does it take. On my laptop, it was taking something like 28 minutes. On the back of my mind, I know when I was running the same experiment on one of my virtual machines on Azure, it was taking around 9 minutes, right? OK, keep these numbers in mind. And this is what we do at this point of time. So this is statistics is about, you know, in my previous example, I said 400 store, 50 categories. Imagine I replace 50 with number 16, and I tell you why we use 16. So imagine you have 16 categories. This is the time that we get for our hyperparameter tuning in the way that we work. So for 10 store, 20 store, 30 store, 50 store, and going up to 90, at 90, we do around 2 hours something. So this is quite a bit of engineering to go from something like a grid search, which takes like 20 minutes, to hyperparameter tuning like this, which you do like 100 store in 2 hours, right? And this is a specification. It's a 16-node cluster, 32 core, 64 gigabyte. So how do we do this? How do we achieve this? So one of the things that we do is this beautiful thing which Profit provides for us. We ditch that, and instead of that, we use HyperOpt. So what is HyperOpt? Some of you are probably familiar with this. So HyperOpt belongs to a group of hyperparameter tuning known as Bayesian hyperparameter tuning. How does it work? So all hyperparameter tuning is about this. You have a cost function like f, and you want to work out what value makes it maximum or minimum. This is the whole story, right? But when you do grid search, you go through 120 options without thinking, is it a good option or is it a bad option? HyperOpt allows you to calculate the probability of goodness of a store according to a hyperparameter. So basically directs your search in that space that you're working with. So the secret of success is that. So you're evaluating objective functions using this train, evaluate, and all that, and compare. But as opposed to grid search or random search, what you do is you don't go through bad hyperparameters. You go through good hyperparameters. Typically, there are 4 stages. Each one of these algorithms, they have like a surrogate function. Here, the probability of a score given hyperparameters. And then we find the best of those scores and kind of carry on. This is an example of one of those algorithms. But we take each one of these hyperparameters, and we just kind of embed them within a Spark UDF. Very good. OK, so let's talk a little bit about the Spark UDFs. Who is using a Spark UDFs? Lots of people are using. So this is very efficient. This is a pattern that we've used for a long time, and I'm going to explain it with the help of an example. So time series, which are stationary, are very, very good. We like them. So how do we check a time series is a stationary? One of the ways that you can do that is using a method called augmented Dickey-Fuller test, right? So I give you a time series, and you look at that time series, and you say, oh, is it a stationary? You go and apply augmented Dickey-Fuller into that and work out if it is a stationary or not. Now look at this data. This is supposed to be a big data table. There is a store here, a store ID 6499. There is a category T33. Imagine T33 is, for example, jeans. And in that date, 2nd of January 2013, the sale was this much. OK, so what we want to do, we want to work out for each combination of a store ID and category, is this time series, which comes from filtering on this, which is giving you all event dates and values, is that time series stationary or not, right? So let's think about it. If you have 400 store and you have basically 50 categories, it becomes 400 times 50 category, 20,000 experimentation that you are doing. You're running this 80 Fuller test that many times, right? So it's lots of execution. So basically, the idea here is, how can we, from this data, produce this? And for each combination of these, produce this value. Is it a stationary, and what is the p-value for that? So one way of doing it, one efficient way of doing it, is using these UDFs. So these user-defined functions, they were a part of a Spark for a long time. So we used to write them in a Scala. Nowadays, since version 2.3 of a Spark, they are available in Python. And we can also write them in Python. So how does it work? You basically have a function foo. In this case, that foo is a Fuller test. And what we are doing is we want to apply this into data frames which are created from the data set at the left-hand side, namely this data set in here. So what we do is we write that function foo, which is calculating basically the p-value and establishes if it is a stationary or not. And then what we do is we take that foo function, and we take this data frame, and we do a group by. We do group by store ID and category. If you do a group by here, you get event date and sales as a data frame. You pass that data frame into this foo function, and the foo function works out if it is a stationary or not and produces the result for us. Extremely efficient. It's so good that we use it everywhere. So we use it for hyperparameter tuning. We use the Spark UDF for prediction, and also various use cases that we have in different parts. Behind the scene is really conducting a map reduce with the help of Spark, which is cleverly designed and is very performant. So if you haven't used this, I recommend using it in your work. OK, there are other parts of the so apart from applying user-defined functions, after we sort this out, we learned over time that there are a set of things that help us to perform various tasks. So for example, hyperparameter tuning is really by nature an embarrassingly parallel problem. So we learned that it's a good idea to kind of create multiple clusters and run them in parallel. So we basically take our stores, and we break them to a bunch of partitions and process them by a different cluster. So this is no brainer. It kind of makes sense. And the other thing that we do is, at the beginning when we started, we were using lots of MLflow. I still use MLflow in my dev phases. But over time, I learned that if I produce delta tables, I can do things much better. So I keep the record of such as best parameters, various metrics, and summaries. So for example, these are some of my best parameters. Why do I do that? Do you remember earlier the thing that I said about if somebody calls from one of our stores? If somebody contacts us, because this data we have available, we can work out what models we used for the prediction. We have the data available in that data frame, so we can basically recreate the profit models. We can recreate the prediction that we have done, and everything as a part of a dashboard is ready for us to interact. We do other things as well. So we want to kind of study what is the evolution of these parameters over time, so that to reduce the computation that we do, we use them also in other parts of hyperparameter tuning. So we keep these records as a part of our system. Another thing that we put substantial energy is in terms of partitioning and size of splits that we use. So we look at how data get partitioned and what are the size of various partitions. We do experiment with this in order to make our analysis a little bit better. OK, so as a way of summary, this talk we started talking about challenging of forecasting at Marks and Spencer. We talked a little bit about scalable forecasting with the help of profit. There are 3 parts into that: hyperparameter tuning, Spark UDF, and optimization. So we have some objectives in terms of moving into larger number of models. So we are thinking, can we do 1 million within basically reasonable resources of computation? This is 4 times what we are doing at this point of time. And also, we are packaging this as kind of a certain modules that we use in different scenarios. So we are looking for data scientists. And if you are interested to work for Marks and Spencer in any of those areas that I mentioned, please scan this QR code and contact us. We have a stall downstairs. We have colleagues here. So if you have any questions, please approach and ask. Any questions?
I think a round of applause first.
Thank you. Gentleman over there.
Yeah, you didn't really talk about it, but since you have so many different models which are all about stock and pricing, do you run any actual tests then? So what tools or frameworks do you use to manage all the tests on so many different models, like A/B testing?
Yes, we have colleagues who are engaged in A/B testing, and we have teams carrying that. I mean, I can ask here. I can put you in touch with colleagues who do that in here, yes. So for this, for example, for the project that I'm working on, we have developed a 3-tier system for interaction with colleagues. We provide these predictions to stores. And then the colleagues who use that prediction, they provide direct feedback to us. So that helps us to work out through this app, which one of these predictions actually worked, which one didn't work. So we log all of those. We do other things as well. So we kind of see how long time people spend on each one of the predictions. So from that, we can work out which one are problematic. We look at those. But we get direct feedback from colleagues. And those direct feedback goes into forecasting of the next step. Yeah. Yes, sir.
Do you find any data external which is good for correlation? Did you find any that you really liked? And what about business impact? Like, would you say your team is profitable, especially now that retail is in recession soon?
OK. Your first question with regards to data related to weather we find very helpful. And we incorporate that into our analysis in terms of regression. So that is an example of that. I don't know if that's the type of things that you had in mind.
Yeah, for sure.
Yeah, with regards to profitability, this is exactly basically to say to colleagues, you have this much time, which action would bring the highest amount of profit to you? So it's very, very directed through the app that another friend asked about. Yeah.
We really can manage the stage as well.
Oh, not? Oh, right. OK, so I have to try not to fall down.
Who's fallen off the stage?
Definitely. No, OK. Yes, sir.
How is it possible to see the interaction with markdown promotions and even offers the general sort of advertising and marketing for the sales predictions as well. So I saw the profit model is very much time series based.
Yes. So I mean, for Markdown, I don't think they use profit. They use other models of forecasting, as far as I know. But in terms of creating more accurate forecasting, we can work with that. I understand the problem that you're talking about. It's just about forecasting within a step in time and how you can. Yeah, I don't think they use profit. This is for another problem. Yeah. Yeah, sorry about it.
So you were saying that labor planning, which is one of the forecasting and retail opportunities, is an area you work a lot on, and I'd be very interesting to know if you could give any insight as to how you use that in terms of like managing employment levels, like seasonal work you offer, or hours offered per position, things like that.
Yeah, so Marks and Spencer puts lots of effort in providing environments so that colleagues have a good working environment. So we do these forecasting on long period basis. So it's just period of, I think, 10 weeks or something like that. So it's not like seasonal in that sense, as far as I know. This is about colleagues. It's about day that colleagues spend in the store. So there are some peak time within the store, and there are time that colleagues are not basically deployed at the store. So how you can just find suitable activities and adjust this together so that we can make the most of the time that colleagues are available. So this is mostly the direction that we are working. Did I answer your question?
Yes, it very much makes sense. Thank you.
Do you have unpredictable seasonality in your, any of your data sets? Like seasonality that's like there's no pattern?
There are a couple. There are a couple of things, there are a couple of problems in that direction. But this particular problem is data going back to 2013. And these are items that we've sold for a long period of time. So for scalable forecasting, we don't have that sort of thing. But I understand we have problems that have really strange patterns. And this hasn't been applied into that sort of. If you want, come after things, maybe we can talk after the talk. Maybe I can hear what you have exactly in mind. Yes, sir.
So you mentioned about the holidays and how that impacts your forecast. But obviously, year after year, the holidays change. So how do you how does that work?
So the framework basically takes care of that. So there are a set of holidays that, okay, there are two ways to do it in profit. So one way is you can get holidays for this country. And then there is this possibility that you can add 2 days, 1 day before and after, and build that into your model. So that's one way. The other way is you can put just specific holiday dates in. So you can add that into the model. Really elegantly handle that. Yeah. Yes, sir.
I think you were just saying, if I understood correctly, are you primarily using the inventory planning for sort of continuity items, or can you cope with newness?
Yeah, so we use them. We use this sort of things for items that we have had for a long time, and some of that for items that we had for shorter period of time. We tune them slightly differently. Yeah. Yes, sir.
Could you expand a little bit on the kind of weather data that you're using? Like what has the biggest impact in terms of predictability? What kind of sources do you use?
Yeah, so I don't know exactly the source of data that, or maybe we don't talk about that, but this is mostly to do with food and things related to food. So certain items of food we can, according to the weather, so weather available from Met Office and all that you can. Yeah. It's just a regressor, another regressor you can add into for forecasting.
I've got a question. So you mentioned neural profit at the beginning of the talk. What advantages does that offer on regular profit? How does performance compare?
Yeah, so if you read the paper, they talk about 50% more accuracy. I haven't managed to tune more than 12% in some of our data. So obviously, it's about autoregression, so you can autoregress into past. So it allows you to look at values in the past and basically create this thing that y of t is equal to a sum of some values in the past. So I haven't managed more than 12% accuracy so far, but I think maybe that's my shortcoming.
I doubt that.
Okay, well, thank you, Behzad. That was a really good talk, and you handled the questions pretty well. Round of applause.